Today I want to talk about one of the first scientific thinkers in modern history. He lived a very long time ago. He lived around 2,300 to 2,400 years ago. He was a Greek. His name was Aristotle. And he's one of the first thinkers in the way that modern scientists think. 2,000 years ago, the Greeks understood some things about the world around them. They certainly asked many, many questions about the things that they saw. They understood, for example, many things about floating objects, and they also understood something about the properties of light. But they didn't understand about motion. They were confused and quite bewildered about some of the things that happened in relation to the motions that they observed. It was Aristotle who attempted to clarify some of this understanding by classifying motion into two types. What you need to understand is that classification was one of the key ways of thinking in those days, and Aristotle's attempt to look at the question of motion began from this idea of classifying motion into different types of motion. He concluded that there were basically two types of motion, one that he called natural motion. Natural motion was the nature of things to return to the state that they belonged in, to their natural state. So, for example, Aristotle thought it was natural that a rock should fall to the earth. He also thought it was natural that smoke should drift up into the air, that these were natural motions and that they would continue until the objects reached their destination and that then they would stop. The reason that Aristotle believed this was the case was that he believed that all things were composed of just four elements. He thought that things were composed of either earth or fire or water or air, or some combination of these four elements. And therefore, he argued that it was very natural for an object to return to its proper or its natural place, which depended on the elements that it was composed of. So a rock, for example, which was made of earth, you would expect a rock to fall because it was composed of the earth. The same with clay or soil of any sort, you would expect it to fall to the ground because it was trying to get back to its natural state on the earth. In the same way, he thought that smoke would drift up into the air because smoke is largely made of air, and so it tries to return to its natural state where it will become stationary again. Something like a feather, that was fairly easy for Aristotle to explain the motion of a feather. Feather, he argued, was composed of both earth and air, and therefore it should fall faster than smoke would fall, for smoke rises. A feather, because it's not all composed of the air, won't rise the way that smoke does, but it won't fall as fast as a clump of clay or a rock will fall because it's not all composed of the earth. So he had a very neat explanation for what he saw as the different motions of these objects on the surface of the earth. Using this logic, Aristotle argued that heavier objects will fall faster than light ones. And that was, by and large, the observations they saw if somebody dropped a feather and a rock. Whether or not they did more exhausting tests in relation to this is not clear. Had they dropped a small rock and a larger rock, they would have seen that this was not, in fact, true. But it is very possible that they never, in fact, did that experiment. The other type of motion that Aristotle classified was violent motion. Now, violent motion was imposed motion. It was motion caused by pushes and pulls from the outside. It wasn't a natural state of motion of the object itself. It was imposed by somebody from the outside. An example would be a person who pushes a cart. When they stop pushing the cart stops moving. That's an example of violent motion, when the cart is moving because the person's pushes make the cart move. Another example would be the wind pushing on the sails of a ship. In those days, of course, the only way ships could move was by the wind, power of the wind pushing on sails. And if the wind stopped, the ship stopped. So if the push stopped existing, then the ship would stop moving. A final example of flood waters. Violent flood waters could move trees and boulders and even houses, and the object would keep moving, the tree trunk would keep moving in the flood waters until the flood waters stopped, and once the flood waters stopped pushing, the tree would stop moving. So all of this seemed very logical and observable in the world around them at this time. But there was a problem with these theories, and Aristotle was very well aware of what the problem was, and it related to what keeps an object moving when the throw ceases to exist. For example, if somebody throws a ball, the ball will keep moving while the hand is in contact with it, but the ball will also move on when the hand leaves the ball and the ball is flying through the air. The problem was that Aristotle couldn't explain how does the object keep moving when the hand is not in contact with it. And he was very well aware of this situation. An example might be, from a later time in history, the motion of a cannonball. After the ball has left the barrel of the cannon and it's in free flight away from the cannon, what keeps it moving? Aristotle would have argued that it was the hot gases behind the ball exploding out of the cannon that made the ball move in the first place. But the question is, what keeps it moving once it's left the barrel of the gun? Of course, in Aristotle's time, they didn't have cannonballs, but they certainly had arrows, and it was to this that Aristotle applied his analysis. Aristotle argued that the reason that the object could keep moving, even though it was no longer in contact with the cannon, or, in the case of an arrow, no longer in contact with the bowstring, was that once the arrow, for example, was in full flight, that the arrow moving forward through the air created a little vacuum behind the feathers of the arrow, and that the air would rush into this space to fill up the vacuum and thereby push the arrow forward. He was quite happy with this argument, and so were many other people at the time, and it would take 2,000 years for Galileo to come along to actually show that this argument was not correct. Aristotle's ideas, unfortunately, in many ways, were adopted by the church in Western Europe, and the church put faith into these ideas that Aristotle himself probably would not have put, and they would accept no dissent from these ideas. So once the church adopted Aristotle's theories in the 13th century, to disagree with them brought very harsh punishments, which included death and certainly imprisonment, which Galileo suffered some years later when he published a book that disagreed with Aristotle and showed why some of Aristotle's arguments were in fact incorrect. So what Aristotle said was that objects move naturally to obtain their natural position in the world, which he regarded as a position of rest, and that if an object was moving, it was moving because some force was pushing it, some violent action was taking place that actually moved the object forward. For 2,000 years, Aristotle was thought to be correct. This notion that objects reach their natural position in the universe even applied to the Earth. Aristotle argued that the Earth was the center of the known universe and that the Earth was at rest because that was its natural position in the universe, the position at rest. And for 2,000 years, people thought that he was correct. Unfortunately, he was not.